basics. So some of us are new to the language, and someone really just wants to learn, hey, how do I get up and running? What are some of the things I need to know to get started? That's the purpose of that particular section, so basics. So we're going to be every meeting. So Eddy Reyes is here. He's founder of Tasqr. If you want to check it out, go ask him. It's a very nice tool. We'll talk about test-driven development principles, challenges, and best practices. Then he will discuss testing tools available in Go. Are there any questions before we get started? All right, without further ado, Eddy Reyes.
Thank you. Yeah, word of warning, I'm suffering from that today. Yeah, so, I think so far I'm good, but my throat gives out. I just start whispering something. I think I'll be all right. So I'm Eddy Reyes. I'm the founder of Tasqr. Tasqr helps startups adopt DevOps without breaking the bank. Some startups out there, they get so lost in cloud operations and in how their application fits in the cloud, especially when it scales, that they go out and hire something called a DevOps engineer, which is fine. The DevOps has a whole host of tools and things like that. Startups have very limited resources, and Tasqr is a virtual DevOps assistant that helps startups basically get their stuff into the cloud. Sorry, what? Oh, I'm on video, okay. Tasqr helps startups get their applications into the cloud, and it figures out what the best way to run that application in the cloud is according to their scale and to the usage. And you use it from Slack. You tell the Tasqr bot, hey, I got something to deploy, or hey, I want to define a microservice and I want to run it on Docker or an EC2 instance or whatever. So if any of you guys are interested in DevOps help without breaking the bank, a fraction of the price of the DevOps engineer, let me know. So I'm going to talk about test-driven development. So normally I give pretty long talks about this. I think I got 20 minutes, so I'm going to take a quick survey about what you guys want me to emphasize on. How many people here, know what test-driven development is? Okay, cool. How many people here use test-driven development? Okay. How many people here want to hear advice and principles and religion about test-driven development? How many people here just want to get to looking at tools and shit? Okay. Skip all this crap. The gist of it is test-driven development helps you create unit tests. Your test is a design spec, and writing tests can be really, really hard, and that's why people forego doing TDD. And my basic advice is TDD forces you to understand your design before you get code down. And the barrier that I struggled with when I adopted test-driven development was that I found it difficult to start writing tests before I wrote code if I didn't understand what my code was supposed to do. And my advice to you would be don't use test-driven development first. Just go prototype, go to town, have fun, explore, learn, experiment. When you think you know what you got to do, don't commit it. Lead it. Start over. Use TDD. And you think, oh, I don't have time for that shit. I barely have bugs because I know exactly what I'm doing. Sometimes there's bugs when I depend on an external service that changes on me or that I misunderstood. But it forces me to have a very deep understanding of my code. So, as I promised, I'm going to skip all this stuff. So, how does testing work in Go? So, Go comes with batteries included when it comes to testing, as it does with lots of things. In Go, if you name your file whatever _test.go, that file has your unit tests. And then with Go, there's this library called testing. It's part of the the standard package. If you look in the I think Golang /package/testing, you can read all about it on their website. But this is what a test looks like. It's a function that starts with the word test, and it can have anything after it. Test my thing, and it takes this object here, this pointer to this object called a testing.t object. And that's basically the test harness that comes with Go. And you can call that thing You can call methods on that thing that fail your test. There's a whole mess of things you can do, like skip a test, fail a test, print logs, informing me what's happening with my test. But Go's pretty like hands off. They just like give me a function and just write your code, and if your test fails, you just call error, and that's kind of it. And then error works just like a log.fatal. Familiar with that? And then the way you run tests is very simple. It comes with the Go binary already, and you just say Go test, and it'll test whatever package you're currently in. So let me show this. Let me show you a live example of all that stuff. If I can get this stuff over. I gotta stop presenting. There we go. So let's get the slide. Let's get this stuff over here. So yeah, I don't know how to like resize my window. I'm not this far away. Anyway, that's what it looks like. So this is my sample Firebase Go client, which you can find on my GitHub. If you go to github.com/ereyes01/Firebase, and if you're interested in using Firebase in your Go code, I'm the maintainer of the library. This runs all the unit tests in my code, and it's that simple. So there's this other really cool thing that comes with Go tests called Go test-race. I can't see what I'm typing.
Do you want me to dim the lights?
Let me try this.
Do you want me to dim the lights? Not in this session.
If you want. Let's see if I can live type over here so it's bored. There we go. Okay, I think that's a lot better. So set up my Go path. Let's CD into source. There we go. Make sure it's all good. There we go. So back to what I was about to show you. Go test-race. So what's that going to do? It's going to run the tests, and you're going to see the exact same output, and you're going to wonder what's the difference. Well, -race is a really cool thing that comes with Go test. It's the race detector. How many people here have used Valgrind back in so Valgrind is a tool for doing runtime analysis of programs, of native programs. And Google wrote a tool for Valgrind called Thread Sanitizer, and that was the first, race detector. It might not have been the first race detector for Valgrind, but it became like the standard one. And then they just yanked that, and re-implemented it in Go. And what that does is, when it watches all your Go routines, or all your, and all your threads of execution, and if it finds that there's two threads accessing the same data and they don't appear to be serialized, it'll just tell you, here's a stack trace. You got a race condition. So it's you kind of just get that for free. You write your tests, and if you have concurrency happening inside your program, and you're not using proper things like channels, and you're getting smart and trying to use mutexes and stuff, that's pretty essential. So that's what Go test-race does.
Yeah, you just would have an example of the race.
I'm sorry?
You just would have an example of that race condition?
Yeah. So let's say you have a global variable, and you start a Go routine that writes the global variable, and you start another Go routine that reads the global variable. Race. I mean, why is it a race? Because that code cannot guarantee who's going to go first, right? So
there should be some sort of locking between the two, or when you go to writing, you should block any readers.
Yeah, but the Go way to do it would be to redesign it such that you use channels, and rather than sharing data, you pass data through channels, and passing copies of data through channel ensures that two Go routines will never write the same piece of data. Does that answer your question? Yeah. Okay. Does that make sense? Anybody Doesn't make sense to somebody? Okay. How many people here are familiar with channels? Use it all the time? Okay. Yeah, so it's like once you get past like the initial Go tutorial, like channels is like the next thing. All right, so let's go back into the presentation. Oh, really? Oh, that takes forever. I don't want to go to that slide. Anyway. So another common thing you do in tests is mocking. And I skipped all the religious stuff at the beginning, but you know, who here is familiar with mocking in tests? Who here wants an explanation of mocking? It's a better question to ask. Okay, good. So you got to mock stuff out in tests. How do you do that in Go? In Go, if your program is interacting with an HTTP server, or is an HTTP server and is interacting with clients elsewhere, Go gives you a really nice shortcut, and it's a library called net/http/http test, and it's a pretty awesome library. And what it is it starts like a fake HTTP server, and it lets you provide it. It lets you provide it a handler, an HTTP handler, and what that handler is insert code here that you want this fake HTTP server to do for you, and then this object will then give you back a URL, like a fake URL for you to pass into your program, and then your program just blindly calls the URL like it was a real server, but it's calling your test HTTP server, your fake one. And if you're writing unit tests and you're talking to some HTTP server and you don't want to call out over the network and instead you want to mock it, this is the ideal way to do it. And I can show you a live example of that in that same Firebase library. So in this Firebase library, let's look at test. Actually, let's just VI it. Can everybody read that? Not all the text is read there. I'm going to get into. I'm obviously not using the standard Go testing stuff. I'm actually going to get into that in a second. But I got this utility function here called fake server. It takes a handler and it returns a test server and a test client. So basically, this test server, this client is actually my client. It's not an HTTP client; it's a Firebase client. But this is how you get the URL out of the server. You just create this object, you pass it this handler, and that URL gives you the URL that would actually hit your fake HTTP server. The way this actually works internally is he actually starts a Go HTTP server and it listens on some, whatever big port number, and it just hands you back that URL. So you actually are going over HTTP over localhost. That's how it actually works under the covers if you ever, if you're curious about reading that code. So let's look at where we use this so you can get an idea of what a test might look like. There we go. So let's see. We're going to override the handler. Let's look for handler. There we go. So this is a fixture for this test, and we're going to get into before each and context and all that stuff. That's the test library I use. But this right here is the implementation of my fake HTTP server, right? It doesn't matter what path into the server you give it. It's just going to call this guy. And it's up to you to basically extract the URL string and query parameters and whatever they called you with. You extract that inside your handler, and then you basically then verify that you got the request that you expected to get. That's the basic idea. When you implement a mock, typically a mock, it's like a proof that you called something and you called it a certain way. And that's what this is right here. It's mocking out Firebase. So this is actually pretending to be Firebase. And when the code does some particular Firebase operation, in this case, it's doing a put, an HTTP put request to Firebase. This is the specification of what that should do, right? Does that make sense? Yeah, any questions about that? Or any? All right. So that's how the HTTP handler works. But of course, I don't know what percentage of the world, it's a pretty large percentage of things are HTTP programs anyway, but invariably you're going to encounter something that is not, HTTP, right? So how do you mock something that, how do you mock some call out to the network, or some custom service that you have to talk to that's not an HTTP server in Go, right? There's some libraries out there like GoMock and stuff that kind of take, in my opinion, strange approaches to this problem. But Go has a really nice tool built in the language that you can just use without having to do anything crazy, and that's interfaces. So if you want to mock something out, if there's a part of your program that calls out to something else, you hide it behind an interface. That's the basic idea. And what you do in your test is you provide a hook to override what the implementation of that interface is. So in your real code, you have an object, that has methods that call the real thing through an interface. In your test, you pass it an object that calls your mock code through the interface. Does that make sense? I'll show you an example of how you can do something like that. So let's look at this thing. And we'll resize this one now. Let's look at, I think it's that Go. So I think it would be in new. There we go. So this method right here inside this Firebase library gives you back a Firebase client object that you then interact with to talk to Firebase. Is anyone here curious about what Firebase is? Quickly, all right. Firebase is it's a JSON data store as a service, backend as a service, thing that you can use. So say if you want to design a program that uses a database, you don't want to maintain a database, and your data is amenable to JSON, Firebase holds all the data for you, and Firebase lets you through REST calls query the data, change the data. So it's an HTTP interface to a JSON data store service. Does that make sense? That's it's more than that, but it's that's the quickest explanation.
Is it similar to MongoDB?
I'm sorry?
Is it similar to MongoDB?
Yes and no. It's similar to MongoDB in the sense that it stores, it uses JSON, but it's as a database, it's not. It's a very crippled database. There's a lot of queries you can't do that you can do in MongoDB. You don't have to maintain it like you would have to maintain a MongoDB, installation, which is the nice thing. But Firebase is mostly the main application for it is real-time streaming. For very simple queries, or if you want to, stream real-time changes to your data, that's what it's good at. If you want to do joins and things, don't use Firebase or MongoDB. Anyway, this thing right here, what's this API thing? It's probably not the greatest name for this, but this API is actually the interface that implements all of the interactions with Firebase over the network. In my unit test, I don't want to call out over the network, right? In my unit test, I'm going to give it a mock API that is going to implement the mocks for verifying that I'm doing the things that I expect to be doing for Firebase. It's going to trick the code into thinking he's talking to Firebase in the test, but really he's talking to my test code. The way you do that is, you just implement your own API for the test. And the real API is, let's see if I can see my Vim is set up. No, my Vim is not set up. My real API lives here. So if you look in declarations, and this is one of the cool things about Go. So in Go, just by saying this is an interface, I automatically have a mockable thing. So I'll just have to implement the mock implementation of it, and then the code implements, the real version of it that actually does the callouts to Firebase. And this is kind of nice because it's sort of the specification of the low-level stuff that ever, all the low-level stuff that ever happens to Firebase. It's all neatly inside this interface, and it's really just two methods. Stream and call. But a user of my library can write unit tests by them providing a mock version of this API interface and passing it into new client. If they pass in nil, it uses the default one. The default one does the actual talking to Firebase. Does that make sense? Any questions about that? So you saw some weird stuff there that didn't look like testing.t. Maybe you're wondering what the hell is all that stuff. So as I told you, Go has a pretty bare bones testing framework. Some people strongly prefer it that way. That's fine. It's good. If you want to do stuff like that. I've been spoiled by certain higher level languages like Python, and I'm used to having a kind of rich functionality in my testing framework. My favorite one is PyTest. Does anyone here do PyTest? If you're doing Python and you're doing PyTest, you can do dependency injection to like dynamically, stick things into your test and monkey patch live code and do crazy stuff. There's nothing like that in Go. Go is not a dynamic language like Python. You can't, dynamically on the fly re-implement basic things about Go, and it's a statically typed language. Not that one's better than the other. It's just, Python, pays heavy taxes for that. Go pays taxes for the way it does things. Everything's a trade-off in technology, it turns out. But there are some tools that let you, let you do things like let you do more sophisticated things in your test harness, like fixtures especially. That was the main thing. I wanted a nice way to specify fixtures, and that's what led me to Ginkgo and Go Mega, and that's the one that I use. So Ginkgo and Go Mega has some detractor. You told me you're not a big fan, and you're probably not a big. You can explain yourself if you want, but and I'm going to speak for you because I'm the speaker. But you're probably not a big fan. Correct me if I'm wrong, because it's not very idiomatic Go in general. And that's true. I agree with you. It's not very idiomatic Go. It's just the way I roll, really. I mean, I just kind of like it. So let's go over what Ginkgo and Go Mega looks like. Who here has used Jasmine in JavaScript? Okay, Ginkgo is a Jasmine clone for Go. It looks a lot like Jasmine on purpose. That's why I think Jasmine starts with J for JavaScript. Ginkgo starts with G for Go, and they're both T's. Or I don't know.
Jasmine's a clone of RSpec.
And Jasmine, I plead. I hide from Ruby. But it's a BDD, behavioral driven development approach to specifying your tests. What you intersperse your tests with like English statements, and there's more to it than that. But that's my ignorant explanation of it. But this is what Ginkgo looks like. So you have these things called describe blocks. And describe blocks at a very high level define like what part of the test is this. Sorry. They have these things called before each and after each, and those are the fixtures. What is a fixture? A fixture is special setup for a test. Like I want to set up my mocks in this fixture, or I want to inject some dependencies, or I want to make certain things, certain conditions about my test true, before I run it. And each of these it blocks are the actual tests, the actual assertions, right? So the basic structure of a Ginkgo test is the high level block describe. My assertions call into my code, my before each, and there's also an after each to clean up things, set up and tear down my mocks. So that's the basic structure, and that's kind of why I went with it, because you can structure these things. And the other really cool thing, I don't think this is a good example of it, but the other really nice thing about Ginkgo is that you can define pretty, more complex dependencies in a test. So let's say there's a fixture that everybody shares, and then you have another, like a mock, say like the Firebase mock that everybody's going to use, and then there's something else you want to mock, like for some of your tests, but not all of your tests. So you can nest blocks. Like you can have describe at the top, and then before each, and then even assertions, and then you can have a nested describe inside of it that describes a sub piece, like a sub module of your test that has other fixtures inside of it. And that's kind of like what I was saying earlier about the dependency injection. In PyTest, you can arbitrarily depend on different PyTest fixtures. In Go, this is kind of like the closest way to get such a dynamic thing. You can just sort of nest these blocks, and you can define pretty complex test dependencies. And of course, too much nesting, too much complexity, you gotta be careful with that. But So the other half, notice I said two things. It's Ginkgo and GoMega. GoMega is an assertion language. So rather than saying if something blah blah, test.fail or test.error, and here's my error, Ginkgo has these things right here. Expect something to be true, be false, be equal to this, be numerically equal to this, and they have a whole host of things. So that it, in keeping with the PDD thing, it reads like natural language. They do have something that's really cool in GoMega, which is testing for channels. And they have eventually channel must send you this, and it works concurrently. And internally, it's implemented with timeouts, so you don't have to do crazy shit in your test. Make your test ugly with timeouts and stuff. The GoMega just does that for you. And also, you could say eventually, or there's another one, eventually, and then there's something that says this must have already occurred. Like this channel must already be closed if I just did this. So it's kind of like a higher order, assertion language. And then the other cool thing about Ginkgo is you might have noticed that there we go. You might have noticed that my test output is like kind of pretty. Go's plain test framework doesn't give you all this pretty output. Like all these dots are past tests, and when you write your tests using Ginkgo and GoMega, it just does that for you, and it gives you this pretty output. Let's inject a failure, because failures were kind of where it moved now. Okay. So let's say, let's try to find the more complex. They're all like simple. There we go. So here's a map that must be equivalent to this other map. And I'm going to gloss over the must be equivalent to versus must be equal to, because it's doing it like a reflect cut. It's like an actual comparison of two maps. But let's inject this failure here. And now let's run the test. Oh, yeah, it's declared not used. There we go. Is this one that hack? Maybe I should search for that. There we go. Let's just do actually, let's just come. Oh, man. I can't see what I'm searching because the screen's. Oh, no. There we go. So I can just blast these 4 lines. Clean up params. There we go. Yeah. So when you get a failure, it actually prints like the entire contents of your struct or your map or whatever, and it actually shows you a diff of like these two data structures are different, and this is what's different. Like you get sort of diff style output. In this case, the whole thing's different because it should be equivalent to nil. Nil map, but it's not a nil map. So you get kind of like cool things like that off the bat with Ginkgo. So there's another one. There's another sort of test add-on to Go called Convey. Convey might be more popular than Ginkgo. I don't know. Does anybody know which one's more popular? Yeah.
My experience, like my dad's in around the Ginkgo is is more popular. Go Convey started before, and but since Omega started, it's a very subjective feeling. But from what I've seen, like Go and Omega, like tend to like shadow a little bit Go Convey. From what I've seen.
Go and I'm sorry, what was the last thing?
Omega and Gingo tend to shadow the Go Convey.
Tend to shadow, yeah. So Go Convey, you think has like fancier features?
Or less.
Less features.
Less,
I see.
I
Yeah.
think that
Less is more.
and
Yeah.
Go, like just went so big and so good that like Go Convey like dropped like a bit in plan.
Cool. Okay. Interesting. I see. Yeah. Go Convey has this really cool. Let me see if I can find a way to run it. Am I out of time? Or?
We got maybe 2 minutes.
Okay. Perfect. Yeah. Try this. So Go Convey. Oh, actually, what's it called? Convey. Yeah, I think I gotta do Go get. Anyway, yeah, I probably don't have time. What I was going to show you is that it starts a browser for you, and as you save files, it automatically runs your tests and shows you your test output like in the browser. So you just have that open. It's kind of like for JavaScript, I guess they got a Karma, that like runs your tests all the time. And, you save and you get like instant gratification.
Or dismay.
Or dismay. I'm weird. I like seeing tests fail. So I get it done.
At least you're doing your job.
Yeah. Sure. Yeah. So they kind of got that. I don't know. Maybe Ginkgo will try to one up them. Maybe not. Yeah. Cool. I guess. Anybody have any questions? Any high-level questions?
Just one funny one. Would you mind to go back very quickly on your var underscore equal and like why do you do that?
I'm sorry. Go back on.
When you do your describe in your global scope, you do var underscore equal.
Oh yeah. Very good question. Yeah, there's a very good reason for that. So what he is asking is, what the hell is that? So in Go, if you just call a function at the very top level and don't return anything, the compiler is going to tell you, what's this? Where's this go? So it's a way to trick the compiler into letting you put a call to a function that returns something at the top level, at the global scope, and basically trick the compiler into letting you do that. So if we take this up, just try it. Yeah, so actually my Vim Go caught it, and it's like, I expected this to be a declaration, not a call, and you're at the global scope. I don't know what you're talking about. So yeah, that's why you need that.
I have a question. I understand before each. What's just before each? I saw something just before each.
Yeah. Okay, so before each runs in the order of implementation, right? So when I'm going to execute this test, right? What Ginkgo will do is it will go at the top of the describe and it'll say, all right, let's run this before each. And if I were to have a second before each, I'd run that one. And then if my assertion was nested inside another describe, it would run another before each in that one. What just before each lets you do is it lets you force that one to run after all the before eaches have been, done. So let's find it. There's, usually what it is, it's like where did I do it? So here I have a nested block. Context and describe are sort of interchangeable. They're kind of the same thing in Ginkgo. This is a nested, test group. So in this one, I want to set this test server and test client to be fake server and give it a handler, right? Handler is a variable declared at the top level described, right? But I haven't initialized handler yet, right? If you were to just say before each, you'd be running on an uninitialized handler, right? Does that make sense? Follow me? So when I come in here, What I want to do is I want to customize what handler does for each different assertion. You see, handler equals, and then there's another handler equals up here. So what just before each does is it actually waits for all the before eaches to run, and then just before each will execute, which allows you to set custom configuration inside each assertion. The code is common. You can avoid it by copying before each every single time and having 50 of them, but I don't want to do that. Ginkgo kind of guessed you wouldn't want to do that either, so that's why they implemented just before each. And this is the kind of thing, and these are sort of like complex things about Ginkgo that you learn as you do more stuff in it. It's a valid knock on the approach that Ginkgo takes. It can get a little complex, but I deal with it because my trade-off is, I want fixtures. I like defining fixtures this way, so it works for me that way. Yeah, does that make sense? Yeah. Any other questions?
So who in here are looking for developers? Okay, so you want to state your name and your company and
Sure. I'm Lou, and I'm with a company that's going to be now called Digital Pharmacist. It's been known as ArcsWiki, but next week we start rebranding. We provide transaction processing and patient or consumer front-end services to independent pharmacies. So all the things that Walgreens or CVS does, mobile applications, website, social media, refill transaction processing, all those things, we take that technology and bring it down to the independent pharmacy. We currently have over 5,000 pharmacies using our products and services. And we had been written mostly in PHP and some Python. And we've been undergoing, transforming all that into Go. And we're looking for Go programmers to help us transform that code over to Go and then to build additional services. We're also looking for DevOps. We run Kubernetes and containers and in the Google Cloud. So if anyone interested in any of that, I'll put some cards on the table.
Awesome, thank you. And you're based out of Austin?
We're in Austin, 43rd in Guadalupe.
Okay, great, thank you. Anybody else looking for developers? What? Where's it? Oh. Okay, so now it's part of our lightning talks, and we're going to have, is Zach? Okay. We're going to have lightning talk from Zach. He works with Agrarian Labs, and he will be, well, I'll let you tell him what you'll be talking about.
Yeah, it's just gonna be really quick, but I found a cool tool called Visor. Just lets you, I'll just like this. Just lets you use your tablet from your computer or whatever device you're using. So I help develop a mobile app. It's really, really helpful because I don't have to constantly switch to the tablet when I'm debugging. Does anybody know what Cyanogen mod is? So this was created by one of the original contributors to Cyanogen mod. So this is Visor. It's not gonna, I don't think we're gonna get a very good view of it, but it's actually a Chrome extension. And after you've installed it, it works really, really nicely. I've only had it crash once. And so you can just literally use your device from the computer. And it goes both ways, so I can use it this way, or I can use it this way.
Does that have just Cyanogen mod ROM, or can it be in the ROM?
No, anything. Just, yeah, anything. It works. That's it. I think Guillaume.
Thank you, Zach.
So Zach is the one who's going to be leading the effort in creating our mobile app using Go Mobile. Do you have any questions for him? He's here. He's free. So before Guillaume comes up, I just want to explain to you Go Basics again. These are for people who are new to Go. We're going to be doing this every time we have a meetup. It's a lightning talk about basics in Go. But you can ask him anything you want. It doesn't need to be anything basic. Second thing, before he comes up, we are always looking for speakers, both in the lightning talks as well as the main presentation. Just let me know, or you can contact me via the meetup. So, Guillaume?
Hello everyone, I'm Guillaume, and today I am going to talk about connection pool in a database, to be specific. Okay, so that's better a little bit. And I would like to start by apologizing because I didn't have the time to prepare my talk. So we're going to improvise a little bit. And before starting to go into the code, let's take a small step back and say, like, what is the connection pooling and why is it important, and etc. So the idea is that when you connect to something, and it can be an external server, it can be Firebase, it can be a database, a cache service, you have that connection. If that connection drops, it's going to be an issue. So like a very common pattern in programming is to have what we call a connection pool. So instead of having only one connection and to use that one, we are going to spin up a lot of connection. So we are going to have that pool, which is going to hold n connection to the service. And after, we are going to have ourselves that are going to, instead of calling the service directly, is going to go through that connection pool. And the pool itself is going to pick one of the connection and available if possible. And depending on the implementation, if you don't have any available, you can either wait and log, or you can just increase the pool and add more workers to your pool. And then you end up with your service. So that has a lot of big advantages. It allows you to scale much more, and to be able to reuse, to have like a concurrent connection, because typically when you have two access on two different threads at the same time to the database, you will have to create two connections, and this is not very efficient, especially if you do that again and again and again. Whereas if we have just a central place with maybe like 10 or 20 connections, we have two threads in the same time that arrive. They both want to call the connection, and they're just both going to pick one of those connections from the pool and use that directly. So that way you don't have all the overhead of reconnecting, the resource needed to hold the connection open everywhere, every time, the cleanup process and everything. And so you can just basically reuse and reuse your connection. And also, of course, the pool itself, without even you using it, is going to be responsible to monitor the connection and is going to make sure that you're indeed connected to the remote and that you have as many connections as you expect and that they're all working together as expected. So that way, when your code needs to use it, it has some kind of warranty, even though it's not a full-blown warranty, but you know that it's going to work because it goes through that pool and it's not just going to be a brand new connection that might fail for X or Y reason. And I'm thinking for those of you who use Docker, especially around VirtualBox, you might have some DNS issue, and like having a pool might just work at the beginning and eventually, because of the DNS issue, is going to drop, and the next connection is going to fail, but because you have everything already open, it might still work a little bit. It's a bit of a stretch example, but it gives you the idea. Okay, so now I'd like to start with a simple example that is going to be a bit more clear, I think, and that example being Redis. And of course, I'm not really sure if I have it here, but very quick guide. Okay, we have Redis here, and in Redis, we have an awesome pool. Okay, can you read? Maybe not. I can go bigger. Is it good enough? So, let's take a quick look at that pool object. Well, what does this do? So we are going to have the die function, and once again, this is going to be our main function. Just like when you try to connect to someone in Go, at least, there is that net.dialer interface that provides you a very simple way across any kind of networking to be able to have a common net.com out of network, so TCP or UDP, and an address. And so this just implements that interface. But because it is not directly a TCP con, it is not a raw TCP connection that you're going to create yourself towards the server. It is towards the pool. And the pool, instead of just doing the connection as you expect it to do, is just going to pick up one of its internal object, which is already connected, and it's going to return this directly to you. So this is one of the awesome things about Go, is that because of that interface, net.dialer, which has just that die function, will return a connection and an error. You can, it's a way you expect to connect. And each time you connect to somewhere, you know that you have this interface and you want this. And when you go to a pool, it just works the exact same way because it's implemented the same interface. And you can just reuse it, and you can go switch from a direct connection to a connection pool without changing your own code and just changing the library that you're using. So that is also a very, very good thing. So you have two quite important, and I'm going to speak a bit more about the database about those two, about the max idle and the max active. And it's pretty, I think, explicit. And it's going to be the max idle is basically the maximum amount of connections that you can have without doing anything. So the basic behavior, when I try to connect, if I have a connection available, I'm going to use it. If I don't have a connection available, I'm going to create a new connection, I'm going to return to you, and I'm going to keep it for the next time. And so as everything is busy, I might grow and grow and grow and grow my connection pool. And that max idle just says that when it grew, everybody is gone. If I have too much, I'm just going to clean it up and to keep small states. And a very similar concept for max active. It's just going to be like how many concurrent connections can I have on my pool. So that way you can define and control your pool. And this one is in particular is Redis, but it's a general concept that works everywhere. And after the rest is just basically internal. But I would like to show you very, very quick that new pool is not very important. That pool.get. So like the way for the driver in Redis in particular, we are going to use the pool. You will notice that I lied a little bit earlier because it doesn't return a net.con, the dialer. It returns a con, which is a special connection structure from Redis. And because of this limitation and they have needing to have more state, we need to go through that pool.get. And that pool.get is going to return that con object. And so each time I want to connect to Redis, instead of just calling Redis directly, I'm just going to call a pool.get, which is going to return to me a Redis object from that pool, and after I can use it directly like I would use it without a pool. And this is due like I just do Redis, and that's why we have the get. But it makes it even more obvious how it works because it's really like that get. We are going to get one connection from the pool, and then I just use that as an directly connection. So instead of going directly, we go through the pool. Now, I'm not going to go through the code of the database itself, but I'm going to talk a bit about it. Once again, Go is awesome, and I think that's why we're here. And one of the awesome things about Go is the database package. And the Go provides the database/SQL package, which implements everything that you should need toward a SQL driver, so MySQL, Postgres, or anywhere. And on top of that, it also provides you a native connection pool. And since I forgot, like maybe 1.2 or 1.3, they added also the set max idle and the set max active, just like we saw on Redis. And so, like by calling your just db.setMaxActive, you can say that I want that many connection maximum toward my pool, toward my database, and the package database/SQL is going to hold your connection pool for you, no matter if it's MySQL, if it's Postgres, or if it's any kind of SQL. If you go through the interface, the default standard library interface of database SQL, Go is going to provide that pool for you. And internally, what it's going to do, just like on Redis, is very, very simple. It's just going to create those connections as they are requested. And once they become available again, they're just going to get back to that pool as idle. And next time I'm trying to connect, I'm just going to look on my idle connection, return the one I want, and then use that in order to go talk to my database. So that was it. Any question? Well, thank you very much.
Great. Thank you. We actually have time for one more lightning talk. Does anybody want to do a lightning talk? Yeah, I'm going to say something. Anybody wants to do lightning talk? Okay, great. So please stay a bit more. The speakers will be here. You can ask them more questions in person. One more note, just want to reiterate, we are looking for speakers, but make sure you're talking about something interesting, obviously. So second, we like it when you come and you bring friends and you bring people. So the more that comes in, the more pizza I'm going to buy. We need more pizza. We have a lot of drinks, so please stay. The last thing is that if you find anything valuable in this meeting, please let us know. And if you want to give us constructive feedback, please let me know. You can either email me after the meetup, or you can ask me today, or you can speak to me today. Any more questions for the speakers before we end? Yes.
Could you spend a minute or two just sharing any links to websites or resources or things for people that are kind of starting out on Go?
Sure.
Kind of get us pointed in the right direction.
Great, that's a great question. We'll
Just before answering this, I'd like to add one more thing, is that we are looking for speaker indeed, but if you're not willing to speak yourself, but if you have ideas of talks, and if you want to speak, to see a talk about something, feel free to come to us with talk ideas, because typically we're always willing to talk, but we don't always have a topic. So if you have something that you would like to address more in depth, feel free to come to us, and we can talk about it.
That's a good point. Actually, the Go basic section in our meetup came about from your feedback. A couple of people, or more than a couple of people, came up to me and said, "Hey, I'm new to Go. I kind of want to learn the basics. Can we do something quick that just shows me the basic things about Go?" So that's how we came about, just to show you how that we are responsive to your feedback. Okay, I'll let Guillaume take you through.
So I'm sure you're familiar with this already, but this document, Effective Go, that can be found on golang.org, and there is a direct link to this. It is one of the most awesome resources for beginners and advanced developers that goes through everything that, not everything, but a lot of things that can be done in Go, and the way Go does it. So I think it's an awesome resource to be more in the Go way and in the Go idiom. So to really understand why Go and why does Go does things like they do. And a lot of people will complain because there's no generic, there's a lot of things that are missing from C++, from Java and everything. But that document, Effective Go, from the official Golang website, explains everything and make it in a way that you can use that as a reference. And I have been using that from the very beginning since I arrived and up to today. I still use that very, very often, and it was a very awesome resource. So Effective Go, and on the same website, the how to write Go code. This is more towards beginners, but typically it's even though Go tries to make a consistent language and tries to make everything in a way that you have only one way to do something, in the practice it's not really true, and you will see that you have always a million ways to do the same thing. And how to write Go code tries to give you the direction, and it complements very well the Effective Go, which tells you how things should be done, and how to write the Go code more on the beginner level. It's going to help you structure that on your code. And finally, on the beginner, this is more on the mid-level to more advanced. Is the actual specification of the language, and it's true in Go and it's true in any language. if you are writing in that language, you should be familiar with the specifications, and you should know exactly what is going on and why when you write if 1 = 1, there is something that happens, you need to know that. And so this is for more like a mid or to advanced level, but it is very, very important and to understand like what is the type, how the type interacts to each other, why the compiler does things and why the lexer does things as well, and this is important. Question?
For anybody who's super new to Go, there's an open source project called exorcism.io, which is basically for picking up new languages. And the cool thing is there's 150 Go exercises, I think, or something. The cool thing about it is you'll get peer reviewed by a lot of people. And so if you're working in a language that's highly idiomatic, that's it. You'll get like 10 people and like, this is not the Go way on there. And it starts out with like hello world, and it gets into cool algorithms and stuff as you go down. So I've done a couple languages like Golang with this tool. I haven't done the but it's really cool. It makes you think about why you're writing what you are. Cool.
The way I learned Go is tour.golang.org.
I was getting to that after that.
Oh, you're good.
Golang. It's also a very, very awesome resource. To be honest, I didn't try it for years, but so I'm sure they improved it since. And but 7 years ago, it was already very good, and I'm sure today it's even better. Like they go from that hello world example toward like a very much advanced channel concurrency, and a very, very like difficult exercise sometimes. But it gives you a hold on the whole syntax, on the whole language, on the channels, on the logs, on like everything that you can do, and like it opens your possibilities once you do that go through. Like you know what you can do, and that is a very good resource indeed as well. And so I have still 2 more resources, but for more advanced. History. So this is more for more advanced programmers, but it's very, very important. So the specification were on the website as well, on the Golang website, and the memory model as well. And the memory model is also very important, and this is where we have conflict a little bit with like a higher level programmers, because they don't really know what's going on with the memory and the lower level things. But in Go, you have to know that you are statically typed and compiled language, and statically linked. So you need to know your memory model. You cannot just trust that because you're garbage restricted, it's going to work. And I like a small story. When I was looking for a job, I interviewed with a few companies as a Go developer, and like more than once, like I end up with companies saying like, yeah, but we tried Go and we dropped it because it was so bad, the garbage restriction was so bad and everything. But then like trying to push it a little bit and to understand, and they were just having like a map and a big map globally, and that grows. And of course, if you do this kind of thing, the garbage restriction is going to get lost, and it's going to be awful. So that's why it's this is a small example, but my point being that it's very important, not as a beginner, of course, but as you get more advanced and more expert, to be very familiar with the Go memory model and like what your memory looks like, how does it work, and it goes with the next one, bring the data race. And that's the first one also, I think, yeah, to talk about the data race. And this, I will post it on the Meetup group tonight. It's an article from IBM on the data race. And this article is actually very, very good. And typically, if you can see, like what can go wrong. Like it's the double shot picker and guns. It's quite funny, but they have a very, very good point, and it's very, very, very interesting. Like what can go wrong? That is and it's very so it's quite also an advanced thing on how to deal with your data condition, and it goes with memory model. And it's very, very interesting. So I will post that tonight on the Meetup group because everybody is a bit complex. Everything that I showed before was on the Golang website, the official website. And finally, this is a much more simple one from Dave Cheney, a very, very good article on the ice cream maker. And it shows a very simple example of something that is impossible, but that happens anyway. And it's something that you need to know in Go, is typically that when you do a variable equal a variable, you don't have the guarantee that it's going to be atomic. If your variable is an interface, your equal is not going to be atomic. And so that's why this code that looks decent, that make you like well pain and that make you like well jelly, it is not atomic. And so like coming from other language, you might think, oh yeah, it's unequal, it's atomic. It is not. So that's why like it's very important to know the Go memory model, to know what a slice is, what an interface is, and like how does it work under the hood. So that way you can avoid the data race and just bad memory model. And I will post again all those links that I talked about on the meetup tonight. And if you have any questions, feel free to get back to us.
Great. That was a really good question. Anybody else?
Thank you so much.
Add on, don't be afraid to read the actual code for like the standard library for Go itself. Okay, because it's all very idiomatic, obviously, and it's a lot simpler than you expect. Because I do C++, and if you ever look at the actual C++ library code, you want to just gouge your eyeballs out for about 10 seconds. But this, it's like, yeah, okay, I can actually read that and understand it. So.
Yeah, along that vein, one of the reasons why I like being a Go programmer, so I was a Java programmer a while ago, and then a PHP developer. And the vast majority of Go programmers that I've met have read the specification documentation. The vast majority of Java developers I've met who've coded for about 10 years in Java never even seen the Java spec before. So it's just a different class of mentality. We actually, but like what Guillaume mentioned, the spec is like one of the things that you actually should read and do read, very often when you're programming in Go. Any more questions?
Or any language. Like this is true in Go, but this is true in any language. And I'm thinking about PHP because I've experience in it. Like people say a lot of bad things about PHP, but once you know the data model, like the memory model, how does it work, like how does the lexer and the interpreter works, you can end up with very, very efficient code and very, very performant code in PHP. And if you know what you're doing. Of course, if you don't know what you're doing and you just go like in trace design or object-oriented and the most awesome thing, is going to fail and it's going to be very, very slow just because you didn't know the memory model, and of course it's going to fail. Whereas the same code, like in Go, would have been very, very fast. And in fact, it's easy to say that Go is better than PHP, but it's just that you did something in PHP that you were not supposed to do just because the language is not meant to do that. And Go is the very same thing. If you try to come and to do Ruby or Python or even C++ in Go, it might eventually work, but it will not be as efficient as it could be. It will not be as idiomatic as it could be, and you will end up with something less efficient and less maintainable. Whereas if you really know what you're doing by looking at the specification, the memory model, and this kind of thing, then you can end up with very, very efficient code that does not require, like I'm not talking about optimization, like over optimization and this kind of thing. I'm not talking about this. It's just as you're writing, because you have this in the back of your head, you know that if you write a function, that is going to impact the memory in a certain way and the performance in a way, so that way it ends up overall making you a better developer to know more in depth about what the language is doing.
Great. So 2 things I'd like to go. Number 1, our next meetup, we will be talking about Go Mobile. So if you're very interested in that, please come to our next meetup. We have drinks. We have some more pizza. You were going to ask something?
No, but since you...
I saw you do something.
I will ask something.
Go ahead.
Are you going to have the meetups on Thursday?
Probably, yes.
Yeah. Yeah, so you're welcome to stay, drinks, and some more pizza. Thank you for coming.
Thank you.
I was just going to say, I don't know what I'm doing with the title.